Okay, we'll take another example for deterministic finite automata. Here, the language should contain language contains strings which contain ABB. In the last example, we had seen ends with ABB. Now the question says contains ABB, and the input symbol is A and B. So first we will write the set of or the basic string that has to be accepted by the automata. Basic string, since it says contains ABB, it can start with anything, end with anything, which can also mean it can start with null, end with null. So your basic string is ABB. So if the ABB is accepted, I can say that this is a valid string. Next, we'll give an example of set of accepted strings. We can start with anything. So I can start with another A, I can start with a B, right? I can end with anything. Correct? So there is no restriction on anything as long as I have this substring A, B, B anywhere as a part of the string, it will be accepted. Even this is a valid string, right? I have ABB twice. It doesn't matter how many times I have it. As long as ABB is a part of the string, it should be accepted. Now, what is a rejected string? All strings that do not have the substring ABB should be rejected. So A, B, even epsilon, since I cannot accept null, you have to have ABB, that is a condition. So I cannot accept epsilon, and none of these should be accepted. Okay, now we have listed down the set of basic strings, accepted strings, rejected strings. Next we will go into designing the automata. So first I'll try to draw the state diagram. Okay, so to draw the state diagram, again I'll first look at the basic string. Since I need ABB, I'll start with ABB itself. So Q naught is my start state. I need a state for accepting A. I need a state for accepting the next B. I need a state for accepting another B. Correct? ABB is done. ABB. Okay, the basic string from start, I have reached the final state. Okay, next, this is not a complete DFA. The reason is I need to have a transition on every input symbol from every state. On Q naught, I know what to do on getting a A. On getting a B, what has to be done? Since the condition is contains ABB, I can start with anything. So I can start with a B as well. Any number of B's is a valid string. So on Q naught, I know on A, on B, I have handled it. Next, Q1 on getting a B goes to Q2. Q1 on getting a A is not determined yet. Since the condition is again A, B, B, I can start with A, any number of A's and then B, B. Still my substring ABB is maintained. A, still my substring ABB is maintained, so it is still a valid string. Again in Q1, I know on getting a A and a B, both cases are handled. Now on Q2, I get a B, I go to Q3. On Q2, on getting a A, what can be done? If I give a self loop on A, what will happen? A, B, B will be accepted. That is not a valid string. Or A, B can also get accepted and that will not be a valid string. So I cannot give a self loop over here. Instead, if I come back to Q1, I can get a A. If I get a A at this point, I'll have to get another B and B to reach the final state. Then I can say that this is a valid string. So A, B, A, B, B. I'll come back to Q3 with a ABB substring. So again in Q2, I have handled A and B. Now in Q3, I am not handled either A or B. Since my condition is contains, it doesn't matter what I end with. So I can just write over here A comma B. Once I have read the substring A, B, B, it doesn't matter what I end with, so I can just give a self loop over here for either A or B. Okay, this is my state diagram. It is complete now because every state has a transition on every single input symbol. Correct. Next, after I draw the state diagram, I just look at the state diagram and fill the state table or transition table. In either way I can call it. State transition table. I have 4 states over here and 2 input symbols. Mark the start state with the arrow, the final state with a star. Then start checking the diagram. Q naught on receiving a A goes to Q1. Q naught on receiving a B remains in Q naught. Q1 on getting a A goes to Q1. Q1 on getting a B goes to Q2. Q2 on getting a A goes to Q1. Q2 on getting a B goes to Q3. Q3 on getting a A remains in Q3. Q3 on getting a B remains in Q3. Now my state table is complete. Okay. Now after this, I am just going to do a small verification. Uh, Before I verify, I'll just write the formal definition. Okay, this is my formal definition. It's a quintuple with 5 elements. I am just going to look at this diagram and explain each and every element over here. Q is the set of states. In this case, my set of states are Q0, Q1, Q2 and Q3. Okay, and sigma is the set of input symbols. It is given as A and B. Delta is the transition table or diagram. In this case, you have given both. There is another representation for writing the delta, which is my transitions. I can also write it explicitly. Q naught on receiving a 0, what it does. Q naught on receiving a 0 goes to Q1. So there are many representations. Q naught on receiving a 1 goes to this is A and this is B. Q naught on receiving a B goes to Q naught. Q1 on receiving a A. I'm just looking at the table and writing. I hope you're getting an idea of how to write the transitions explicitly. These can be asked in competitive exams. This format can be asked, and you can be given blanks over here. Fill in the blanks. Given a given a DFA with some transitions, and blanks can be given where you'll have to fill enter data. So there are many representations. Q2 on receiving a A, Q1, Q2 on receiving a B, okay. So this is a transition, and Q naught is the start state. F is the set of final states. So I'll just put it in curly brackets. In my case, I have only one final state, which is Q3. Okay. Now, once this is done, I can show the set of, give an example. I'll take an example of an accepted string. Let's say I'll take AABB. I'll just take another B just because it's a contains condition. Okay, so how to show an example? I start with the start state and read the first input symbol A, Q naught on receiving a A. Q naught on receiving a A goes to Q1. Q1 on receiving, now Q1 and receiving the next input symbol. Q1 on receiving a A goes to Q1. I am in Q1 still. I have read the next input symbol B. Q1 on reading a B goes to Q2. Q2, now I am in Q2 state and I am reading the next input symbol. Q2 on reading a B goes to Q3. Now I am in Q3 state and I am reading the next input symbol B. It is remaining in Q3. Now you can also verify whether you have finished the string A, B, B, B. A, B, B, B. Now you are reading the end of string character. Check. Q3 is your final state. You have read the end of string character. That means this string is a valid string. You can accept it. Okay. Now we'll take another example of a invalid string. What will be an invalid string? Whatever does not contain the substring ABB. So I'll just take a substring ABA or a string ABA. Okay. So always I'll start with the start state and the first input symbol. Q naught on reading a A goes to Q1. Now I'm in Q1 state. I read the next symbol B. Q1 on reading a B goes to Q2. Q2 on reading the next input symbol A. Q2 on reading a A goes to Q1. You can also verify ABA, ABA, right? ABA, ABA. Now I have read the end of string character. Q1 is a non-final state. It's not a final state, right? Only Q3 is a final state. So since Q1 is a non-final state and I have read the end of string character, I will say this is an invalid string and it will be rejected.